Hi guys, welcome to another episode of MrLopezClasses.com. This is the chapter 9 of our marine diesel engines class. In this chapter we are going to talk about the piston and piston rings. How important are those vital components inside of a diesel engine? This is the typical piston on the head. We have the small pocket or crown, and on the side of the piston we have three groups. The first two groups are for compression rings. The first one and the second ones are compression rings. The group number 3 is for oil controller. What is the meaning of that? The third one have a small cavities like this. Let me show. The first one and the second ones are compression rings. And the third one is the oil controller. The oil penetrates from the bottom, from the oil pan or the oil jets, and the oil passes through those small drills and return in the bottom. I have a video that right now we are going to check that one. In other words, in the group number 3, there are small cavities that allow that the oil return into the oil pan in order to keep the cylinder wall lubricated in this area, the cylinder wall lubricated. This is very important. Okay, with this information, this is the name of this phase is the piston skirt, and the pin is located inside. We are going to remove the pin. I am going to explain the procedure to remove the pin. The pin connects the piston with the connecting rod. This is the connecting rod and the bearing that we studied in the previous episode, the caps of the connecting rod, and this is basically the nomenclature related with the piston and connecting rods. Okay, my friends, the life of the piston. The piston is basically the element that receives the majority of the detonation, the element in the combustion chamber that receives the majority of the power of the detonation. This is the element that transmits all of this power into the connecting rod. The connecting rod produces rotation on the crankshaft, and the crankshaft produces the final output torque. Okay, this is an important element. The quality of the piston is very important. If the quality of the piston is not good, the life of the piston is short, and the life of your diesel engine is short. The diesel engines, the characteristic of the diesel engines is the quality of those engines. The majority of the diesel engines runs around 1 million of miles in comparison with a typical diesel engine that the average is around 200,000 miles. Is 5 times. Why? Because the quality of the materials, and especially the piston have a special material that I am going to explain right now. What happened with those materials? What are the materials recommended for the fabrication of pistons? If you remember, in previous episodes I explained the difference between cast aluminum and forged aluminum, and the difference between cast iron and forged iron. The main difference is the organization of the molecules, the organization of the structure in between cast material and forged material. The forged material is forged in a special equipment, the hydraulic equipment, and organize the structure better. The cast material, cast aluminum or cast iron, have too much impurities, too much bubbles of air internally, too much pieces of silica, too much pieces of carbon deposits. The forged material have a less amount of air, less amount of impurities, and the organization of the structure is better. Let me show to you a couple of pictures. This is the typical picture, picture of a cast aluminum. If you see the picture, there are a lot of bubbles of air, there are a lot of impurities of carbon, And yeah, this is the structure is not organized. This is the structure of cast aluminum, and this is a picture of the structure of forged aluminum. If you see, the structure is more organized, it's better, no impurities, no bubbles. What is the problem with the bubbles internally in the piston? We are going to talk specifically about the bubbles inside of the piston. If the structure of the piston is cast material with too much air, too much bubbles, when the temperature of the piston increase, the diameter of the bubbles increase, and it's possible that those bubbles expand cracks and propagate the cracks, and for fatigue, suddenly the piston is broken. Yeah, this is the problem. The air inside of those structures expand with the temperature and propagate cracks. This is not good, especially in elements like the piston. The elements are elements that are in cycling operation up and down at high pressures and high temperature. You remember the pressures are over 3000 psi and the temperatures are superior to 1000 degrees Fahrenheit. Excessive temperature, excessive pressure. If you have air inside of the structure, those bubbles expand and propagate cracks. That's not good. That's catastrophic in some situation. For that reason, the design of the piston for diesel engines, the majority are in forged aluminum and forged steel, both of them. Both of them are the preferred materials used in the fabrication of pistons. Forged aluminum and forged steel, special material, special steel. This is good if the pistons are forged pistons. They run with a lower temperature. They run with lower temperature in comparison with the cast material. It's around 20% less temperature. Excellent, excellent. And they avoid the propagation of cracks. Yeah, they are crack resistant because the surface is hard in comparison with the cast material. Other advantage of the forged pistons, they have a greater strength in comparison with cast pistons, and they support higher pressures and they produce higher output horsepower, around superior to 500 horsepower. And of course, the pistons, the forged pistons, improve the fuel efficiency of the engines. As you know, the diesel engines have more than 40% more efficient than gasoline engines. This is a big difference between gas and diesel. They are 40% more efficient in comparison with the diesel engines. Okay, my friends, other important difference is that the torque produced for diesel engines is double in comparison with the torque produced for gasoline engines. This is other important consideration, especially in marine applications where the torque is the most important factor, because with higher torque I can better thrust because I need less pitch to advance forward. Yes, the torque is the most important consideration for marine calculations. Other important consideration is the durability of the piston fabricated in steel is 4 times the life of the piston fabricated in aluminum, forged aluminum. Yeah, the majority of the big diesel engines, like the engines produced for Wärtsilä, they use steel pistons because those engines runs at low RPMs. Yeah, the majority of those big engines, diesel engines, they rotate at low RPMs in comparison with the medium and small diesel engine that they rotate at higher speeds. You see, between 2000 and 5000 RPMs. Okay, this is an important consideration related with the material of for the fabrication of pistons. Other important consideration is in relation with some codes used for the engineers in order to improve the efficiency of the pistons. For example, when the people use ceramic materials on the head of the pistons in order to improve the heat transfer, and in order to reduce the volume of the combustion chamber to increase the compression ratio. This is a very common technique used for engineers dedicated to convert regular engines into high performance engines or race engines for race car, race boat. They added ceramic materials on the dome, on the head of the piston, creating a dome like this one that you have here on the picture. But this is not recommended in diesel engines because remember, the diesel engines work at higher temperatures. What happens if that piece of ceramic is fractured, is cracked? Those pieces of ceramic are in movement inside of the combustion chamber and destroy the face of the valves, destroy the head, and produce catastrophic consequences. I don't recommend added ceramics on the head of the piston because the temperature of diesel engines destroyed soon or later those coatings of ceramics, and you introduce catastrophic consequences in the engine. Exactly the same with the anti-scuff. The anti-scuff is a lateral protection used in some medium or small diesel engines and gasoline engines. This is good because reduce the friction in between the piston and the cylinder wall, and improve the cooling of the piston. This is once again is good in medium and small diesel engines or in gasoline engines. Yeah, but in heavy diesel engines with the supercharged diesel engines, I don't recommend that protection. It's good in medium and small diesel engines. Other important recommendation for diesel engines, for diesel pistons, is the lubrication in between the piston and the cylinder wall. The lubrication is other element that increase the durability of the pistons. Yes, the oil is coming from the oil jets in the bottom. It's a jet of oil that is sprayed in the bottom and enter inside of the piston. However, inside of the piston have a small drills connected with the third groove, the bottom groove, and the oil circulate through the bottom of the oil to the oil pan, and once again the jets inject oil and the oil return. In other words, the function of the oil jets is introduce the oil on top and spray the oil in the bottom of the cylinder liner, and at the end of the day the oil enter here, goes over there, and return. This is the path of circulation of oil. If you check this picture, we have oil until the bottom ring, piston ring. We don't have oil going up from this point and up. In other words, if you have oil in the combustion chamber, what is the symptom when you have oil in the combustion chamber? Oil entering in the combustion chamber during the explosion. What is the symptom? Yes, blue smoke. If you have blue smoke, the majority of the technicians say, oh, this is a problem with the piston rings. No. What is the symptom when you have problem with the piston rings? Yes, low compression. Oil in the combustion chamber? No, because we have the third piston ring, the oil controller, that allow that the oil enter here and return into the oil pan. The top piston rings are compression rings. Those rings seal the combustion chamber properly. Yeah, those rings, of course, if the rings are broken or if the rings are aligned, you have pass. But in normal conditions, the oil no penetrate, no enter in the combustion chamber if the rings are in good condition, in acceptable conditions. Yeah, okay. In some specific case, the rings are broken, and of course, the oil pass. That's possible. But in general terms, no. In general terms, the oil return into the bottom through those holes. Those holes, let me show to you. In this particular video, we have this example. You see, those holes internally, the oil enter over there, where I introduce the oil and goes out to the third ring. Yeah, you see, this is a specific. This example, I have another example here. Let me show to yours. In this example, those are the drills internally on the piston, and the oil enter over there. I am going to introduce a little amount of oil over there, and if you see on the third ring, piston ring, the oil is going out. Right? This is very important. Okay, we are going to return to our picture, this picture. Okay, on top here in the combustion chamber, we have fuel and air. Fuel and air. And no oil. What happens if I have oil in the combustion chamber? Where is coming that oil? Yes, it's coming from the valves. You remember the valve guide? If you have too much play in between the valve and the valve guide, and the seal of the valve guide is not good, probably the oil penetrate in between the valve guide and the stem of the valve, and the oil enter in the combustion chamber. Yes, in other words, if you have oil in the combustion chamber and you have blue smoke, you have head problems, head valves problem. If you have low compression, you have piston rings problems. We are going to talk at the end of this episode about those specific problems and the solution in each case. All right, those are the function of the oil jets. The oil jets are very, very, very important. Don't forget, this is another good example. The oil penetrate here. You have the drill here. The oil penetrate over there. This is oil. And the oil goes down. On the top rings, the fuel and the air enter and penetrate only until the second ring. Yeah. Of course, if the rings are broken, you have low compression because the air and the fuel pass directly on the bottom. Those are extreme cases. In regular operation, if the piston rings are in good conditions and the cylinder wall is in good conditions, never the air and the fuel pass into the bottom. And in the same way, the oil never penetrates the combustion chamber because it's supposed that the oils are working, the piston rings are working in good condition. Okay, this is very, very important. I have a good video that I want to share with yours about the different type of pistons used in marine applications, in diesel engines for marine applications, the materials and the construction. This is the video, and let me explain something about that video. All right. Okay, those are the pistons, aluminum. In this particular case, the piston have a couple of resist pockets to protect the valves. This is a diesel piston, but the head is not the typical head with the pocket. You remember? In this particular case, only have a space for the valves. But it's a diesel piston. This is a piston used in an Onan generator. The engine is a Cummins engine. Okay, right? This is aluminum. This is forged aluminum, and this is another other forged aluminum piston with the pocket. This is a forged aluminum. with inserts of steel on the piston rings grooves in order to protect the piston rings. I am going to show to you. Those are the inserts. Those are the inserts in steel used to protect the piston rings and used to dissipate heat. Remember that the first and the second one groove are for compression piston rings, and the third one is the oil controller. Yeah, those are the inserts in steel to protect the piston rings, and this is the button. This is the number 3 oil controller. You can see one drill here and the other drill over there. Those are the drills, exactly. This is forged aluminum with steel inserts, and exactly those are the drills. Those are the drills to communicate in the button. And this is the number 3. This is completely in steel. It's a heavy steel, chromium, molybdenum, and vanadium. It's a heavy steel. Also have inserts in other heavy material to protect the piston rings, and they have the plain bearings on the pin of the piston. Right now we are going to check that. Okay, this is the piston in steel. Those are the grooves. The third one have those drills to communicate, to return the oil in the button. Yeah, that's completely fabricated in steel, and those are the piston ring, the plain bearings for the pin. That plain bearing in bronze with phosphorus, you remember? Those are the plain bearings. This piston is fabricated in steel. It's not aluminum. And this piston have a special steel protection in order to protect the piston rings. Yeah, this is very common in high performance diesel engines, supercharged. Yeah, this is the plain bearing for the pin, completely fabricated in steel. Those are the most common type of pistons: forged aluminum and forged steel, both of them, with the head with the pocket, in order to concentrate the force and dissipate sound. All right, perfect. And right now we are going to talk about the different type of construction. This is those are steel, forged steel, and those are aluminum, forged aluminum with the inserts in steel to protect the rings. There are a couple of piston with the other groove in the bottom, or other oil controller. If you see this one in the bottom, have more drills, exactly the same like this one. Both of them are oil controllers. And now we are going to talk about the piston rings. And there are 3 types of piston rings. Compression rings located on top. This one and these ones are compression rings, and this one, the ring located in the third group, is an oil controller ring, and the oil enter over there, penetrate through the hole and return into the bottom. This is the path of circulation of oil, because the oil controller ring is hollow. It's hollow, like the oil controller ring that you have on the screen right now is hollow, and the oil controller ring allow that the oil pass and return into the oil pan. Those are the typical piston rings alloys. And now we are going to talk about the alloys for piston rings. The most common type of alloys for piston rings have excessive amount of chromium, molybdenum, vanadium, titanium, nickel, and copper. And if you remember, on the crankshaft, we have high concentration of chromium and high concentration of molybdenum. Once again, chromium and molybdenum. Very important. Remember my recommendation: take a sample of oil and send the sample of oil to the laboratory in order to analyze the content of other metals, other minerals, other additives in the sample and analyze what is the situation, what happened with your engine, where is located the problem, and how can you solve that problem. In this specific case, if you found it in the report of the oil sample excessive amount of chromium and excessive amount of molybdenum, you have two possibilities: the crankshaft or the piston rings. How can you identify if it's the crankshaft or if it's the piston rings? Okay, if it's the crankshaft, if I have deterioration in my crankshaft, if I have a dents on the surface of the crankshaft, on the main journals or on the rod journals, probably I have one code activated in my computer. What is the name of that code? Yeah, knock sensor. If you have excessive amount of chromium and molybdenum, and the problem is on the crankshaft, probably you also have high content of lead and high content of zinc, because the babbitt is gone. For that reason, you have the knock sensor activated, and also you have the pressure on the oil pressure gauge below 40 psi. This is another indication. All right. What happens if I have high level of chromium and molybdenum in my oil sample, and the problem is not on the crankshaft? Probably the problem is on the piston rings. And what is the consequence? What is the consequence? I have low compression. I have low compression. What happened? What is the symptom when the compression of a diesel engine is too low? Probably suppose that you have a VA engine, diesel engine with 8 cylinders, and you have a low compression in 4 cylinders. Probably you have a pure fuel going out through the exhaust pipe. Yes, if you check outside of the boat on the water, you found it a lot of fuel, a lot of diesel over the water. Yeah, this is the typical consequence, because the compression is not enough, and when the fuel is injected at the end of the compression, the pressure is not enough and the temperature is not enough, because the compression is low, and the fuel never ignites, and the fuel goes out through the exhaust pipe. Right? This is typical consequence when you have low compression, and of course you have misfiring. The engine is running not soft. You have vibration on the engine. All right, but we are going to analyze all of those situations one per one. You know, each day when the class advance, we have more and more codes, more parameters to identify where is the problem. Okay, my friends, don't forget the piston rings. The piston rings enter directly in the groove. For that reason, as you see on the video right now, the piston grooves should be properly cleaned with the tool that I am using in this moment, in order to clean the groove properly. And at the end, you can verify that when you install the pistons, when you put back the piston rings again, you introduce the piston ring, and you can verify if the piston ring close properly with your hands, with your fingers, and you verify that the end gap is appropriate. If the piston rings close properly, it's because the channel, the groove, is completely clean, and the piston rings enter properly, open and close properly. The diameter of the piston ring is critical. As you see in the video that I have on the screen right now, the procedure to verify if the diameter of the piston ring is okay is introducing the piston ring into the cylinder. Yeah, and now with the face of the piston, you try to locate the piston ring straight, exactly like I am doing on the video. And after that, with the feeler gauge, you check the end gap recommended by the manufacturer for that specific engine. You select the filler gauge and you introduce the filler gauge. If the filler gauge no enter, it's because the end gap is too close. And you need remove the piston ring, go into the file, put a file on the vise, and sand it a little the end of the piston rings. And once again, introduce the piston ring into the cylinder, straight the piston with the face of the piston, and now once again check with your filler gauge and verify that the filler gauge recommended enter properly in the end gap. Okay, if the filler gauge enter properly, it's because those piston rings are the piston rings recommended. Before you install the piston rings, the procedure to install the piston rings on the piston is with this tool. You open the piston ring carefully, only the diameter necessary to introduce the piston. If not, you break the piston rings. With one finger, you keep the piston ring in one side, and in the other side you introduce, correct, and right now the piston ring is inside, and you can move with your fingers in order to verify that the piston ring is moving free. At the end, with your finger, you can close the piston ring in order to verify that the piston ring closed properly, and you do the same procedure with the other piston rings. This is the procedure to install the piston rings. Alright, why I'm going to repeat again. We are going to use the tool, open and close. Be careful, open the piston ring only the space necessary to introduce. With the other finger you introduce the ring on the groove, and you release the tool slowly. That's the procedure. Okay, in order to verify the clearance of the piston ring, is the end gap can be verified with the filler gauge, like I explained in the video before, and other tolerance is the axial clearance. Is also with the filler gauge, is in between the ring and the piston groove. You introduce the filler gauge and you verify if the tolerance is according with the tolerance recommended by the manufacturer on the service manual. Exactly the same like I am doing in this moment on the video with the filler gauge and the piston ring. It's not complicated. You check for axial clearance and you check for end gap. The most important is the end gap. The end gap is critical. Let me explain something. What happens if the end gap in a piston ring is too close? Is too close. What happens? What is the consequence? Immediately you start the engine, the temperature increase, and probably in a couple of minutes the piston rings are broken and the piston expand and seize the engine and block the engine. This is the consequence. This is an ABYC question on the ABYC test. If the end gap is too close, the engine, immediately you start the engine, the temperature increase, and probably because the piston rings expand, they don't have a space to close and they are broken. Alright, this is the consequence. What happens if the end gap is too open? Probably you have a loss of compression because the end gap is too open. Probably the compression is not enough. Alright? If the compression is not enough, you remember the consequence. Probably the pressure is not enough, the temperature is not enough, and when the fuel is injected, never ignite and pass directly to the exhaust pipe outside. Right? This is very, very, very important. The oil controller ring, there are 3 types. Okay, the first one is the oil controller ring with the spring inside. It's exactly the oil controller ring that I showed in this moment on the video. Yeah, the spring have a special wire inside, and when you introduce the wire into the spring, you close the loop, and that loop enter inside of the metal, the hollow metal of the ring. Okay, and this one should be installed in the third group. The first step is introduce the spring, and after that, with your fingers, carefully you introduce the external element. The other element is like a sandwich. Is the spring in the middle and two thinner piston rings in each side, like a sandwich, like you see in this moment on the video. It's exactly like the sandwich that you have on the video, and those three elements are installed in the third groove of the piston, the oil controller. Yeah, there are other engines with 3 or 4 small thinner piston rings located in that groove. The 4 thinner piston rings enter in that groove, and they have too much space, and they allow that the oil pass in between them and return into the oil pan. This is the situation with those oil controller rings located in the third groove, and in some cases in another 4 groove in the bottom. If you see in this moment in the video that I have over there, this is the typical packet of piston rings for a Perkins engine. I replaced those piston rings in a Perkins engine, Perkins 408 that I repaired a year ago, and they have 5 type of piston rings. The number 1 and number 2 are compression rings. Number 3 are the thinner piston rings. The number 4 is oil controller, and the number 5 in the bottom is for other oil controller. Those piston rings comes in this envelope, and the envelope in the box. Yeah, those are the original piston rings. This is the envelope with the 5 piston rings, and this is the common type of piston rings for Perkins engines. There are different shapes for the piston rings. The most common is the rectangular. The majority of the piston rings, they have a dot. They have a dot indicating that this is the face up. The piston ring should be installed with the dot facing up. All right. In the example that you have on the screen right now, those are the dots, and the piston ring is facing up. Normally, you have those dots in the piston ring number 1 and the piston ring number 2. In other words, in the compression piston rings. Yeah, use the tool appropriated to introduce, to remove and replace those piston rings. Those piston rings, normally the top one is completely rectangular. The top one is completely rectangular. The second one, in some cases, is the keystone. The second one, this one. This one is for the second compression ring.